Morning, my name is Makuji, and this is Topaz tutorial. So we are doing a topic on phase 102, which is forces. So now we are looking at two type of forces. I said generally force can be grouped into two categories. Now we have many forces, but broadly we can group force into two categories, which is one, net forces, two, exerted forces. So I'm going to be fast so that we can quickly finish this. So what is net force? From the word net, it means combination of many forces. Net force is not actually a force on its own, but the total force acting on the body. From the word net, net means total. So net, you see the reason why net force is not a force on its own. It's not a force. It's just the total force acting on a body. So for example, when you enter a keke napep in UI to Topaz tutorial at Abadina, Abadina is also at UI. Okay, that's where Topaz tutorial is located. So when you take a keke napep in UI to Topaz tutorial at Abadina, the force acting on the car while moving are two forces. One is the horizontal force, the second one is vertical force. Now, under the horizontal force, the first thing is the frictional force exerted by the road to repel motion. Frictional force is always against motion. No, so the second force is the force exerted by the engine of the car to move the car forward, also known as applied force. So there is a force applied by the engine to move the car forward, while there is a frictional force acting opposite to the applied force. So those are the horizontal forces. Now there are vertical forces also acting on the body, on the car, on the keke napep. The first vertical force is called gravitational force, exerted downward by the head on the car. The head is always exerting gravitational force on us and on every object. So the second force is your weight. You are sitting in the car, so your weight is also acting downward, is also acting downward on the car. Now the there's a force that will counterbalance, that will balance the two forces that is acting downward. That's normal reaction. That normal reaction is acting upward to balance both your weight and your gravitational force. So the vertical forces cancel each other. It cancel each other. So there are two forces acting downward, and there's one bigger force that is balancing both two forces that is acting downward. So those forces cancel each other. So now vertical force cancel each other. What now causes acceleration is the horizontal force. Horizontal force is one that causes acceleration. It's not vertical force. Okay, because vertical forces have cancelled each other. If not, the car will be floating, will be moving both upward and forward. But the car, we want to accept, want to just agree that it's only moving forward, not upward. So vertical forces have cancelled each other. So now the F net equals to MA. The F net equals to MA. Remember, there is no vertical force again. We are dealing only with horizontal forces. So what's the forces acting on the car in horizontal motion? Is the applied force and the frictional force. So we will now say FA minus FR equals to MA. Why? Because FA is greater than FR. If FA is not greater than FR, the car will not be moving. So if the applied force is not greater than frictional force, the car will not move at all. So FA minus FR equals to MA. So the F net is your FA minus FR. So you can see that the F net, the net force is not a force on its own, but it's a combination of applied force and what? Frictional force. So know that F net is not a force on its own, but the combination of what? Frictional force and applied force by the engine. Now this scenario 2. Let's go to the second scenario. Assuming you are standing and someone is pushing you, another person is pulling you. You are standing, somebody is pushing you, another person is pulling you. So the F net is also equals to MA. But your F net is what? The force created by the push minus the force created by the pull equals to MA, because it's opposite. Pull and push are opposite. So that is, if we are saying F push minus F pull, that means F push is greater than F pull. Okay, or we can also say F pull minus F push, that means F pull is greater than F push. So the one that comes first is greater than the second one. So if it's a bigger person is pulling you, that means it will be F pull minus F push. Or if a bigger person is pushing you, that means it will be F push minus F pull. Okay, I believe you should know that. So F net is not a force on its own. It's the total force acting on the body. Now we have two types of net forces. We have two types. One, the net force that causes linear motion is also known as Newtonian forces. We have two types of net forces. One causes linear motion and the other causes circular motion. So the one that causes linear motion is known as Newtonian forces. Is where we have F net equals to MA. F is not equals to MA. It's the net force that is equals to MA. Because if you say F equals to MA and you don't know that it's the net force, okay, What F is, we have a lot of forces. We have gravitational force, we have push, we have pull, we have tension. So we cannot categorize the F. So that's why we are saying that the F is net force. F net equals to ma. Okay, another force is the net force that causes circular motion is also known as centripetal force. That's the net force that causes circular motion. It's known as centripetal force. That's F net equals to what? Mv square over r. So in next class we'll do calculation, and you'll see the application of net force. You have to understand net force for you to even understand physics, because we use it a lot in every area of physics. So you know that, oh, the force that we are, so when you say F equals to ma, it's not just single force, it's the total force acting on the body. So we'll do calculation and you understand better. Thanks for being part of this class.